This is a contributed presentation to AKM 40 in TRB 2025. The title is Fungal-bound granular materials, concept, opportunities, and challenges. I'll start with the biological background. So the life on this planet are split into 5 kingdoms. The first is maybe lesser known, potists. They contain elements or life like algae and amoebas. There's also bacteria that make a kingdom. And then we have plants, the kingdom of plants, and kingdom of animals. But there's also a 5th kingdom, a kingdom of fungi. Fungi grow in this way that spores consume or metabolize a substrate, and then they generate hyphae, which are very thin, long tubes, thinner than human hair. And then hyphae increase in length and size and become more entangled, and the outcome is called mycelium.
Most fungal life begins with a spore. From each spore grow tubes called hyphae, 5 times thinner than a human hair. Their most urgent task is to find food, so they start exploring. As these tubes branch and fuse, they form a delicate web called mycelium, which can grow into a network with billions of hyphal tips.
So that was an excerpt from the film Fungi, a Web of Life from 2023. So here's the concept. We take aggregates and we mix them with a mushroom spawn or inoculated substrate. Here in this case you can see a substrate that is sawdust. Sawdust is a combination of cellulose and lignin. And here's the mixing process. It can be done by hand if these are small quantities, or it can be done with a mixer. This is done at room temperature. Then there's a compaction phase. In the laboratory, we use a compactor like the gyratory compactor, for example. In the field, you have a layer that is compacted with rollers, vibratory rollers. And then we wait. And during the wait time, mycelium grows. As the mycelium grows, the hyphae encapsulate the individual aggregates. This is a close view of a small aggregate about 1 millimeter in size. As you can see, it is being encapsulated or fish netted with hyphae. And after the wait time, we extract the specimen in the case of laboratory compaction, and the growth of the mycelium happens inside the pore space, and it encapsulates all the aggregates and makes a rigid specimen that can contain its self-weight and has a strength and modulus. Here's a close-up picture of several cylinders that were prepared in the laboratory using a gyratory compactor. Here's a video that gives a better intuition on the final product. So again, it's the aggregates that are mixed with inoculated substrate, compacted, and then after some wait time, you get these rigid specimens. Something about the project. The project name is LOOPER. It stands for Low Energy Biorenewable Paving Materials. The period in which the project runs is 2024 to 2027. We received funding. The project team received funding from EUDP. That's the Danish Energy Technology Development and Demonstration Program. The budget is 20 million crowns, which is almost $3 million US. And we have 3 partners. Visibilt. Visibilt is a Copenhagen-based startup company, and DTU us, we are the Geotechnics and Geology section, and we have Munk Asphalt, who is a material producer and a paving contractor. Here's a overview of the team members. I'll point out Line. This is in fact her brainchild. She came up with the idea of using mycelium for road construction. We have Alexi and Anna that are helping with the scientific aspects, and Nike is a PhD student that works in the lab, and the specimens you saw he prepared. So we are looking at the new material kingdom, in fact, because we have unbound granular materials. These are called often UGMs, bitumen-bound granular materials, BGMs, and cement-bound granular materials. These are CGMs. And now we're looking at fungal-bound granular materials, which are FGMs. The idea is environmentally friendly because, first of all, the mycelium or the fungi are nature-based. They are not manipulated in any way. And they have self-healing capabilities. They are also self-repairing. And the carbon footprint is low because there is no heating needed for the aggregates. And when we look at the construction side, it's also considered construction friendly. Again, no heating is required. So that saves a step. And also we can use the same equipment and facilities as we have today for producing granular materials or asphalt. We are, of course, facing challenges as this is a new paradigm or a disruptive approach. We need to cover material or mixed design aspects. We need to learn how to model the outcome. So we need constitutive models, and we also need laboratory techniques to characterize the material, and need the structural modeling and codes that can accept this new kingdom of materials. And of course, we need full-scale performance history and also full-scale experience. This would lead to another set of challenges, which is how do you analyze and how do you design? And we need procedures and guidelines for these. We need the material and construction certifications and also procedures. And we need to cover quality assurance, quality control techniques. And we also need to look into reuse and repair guidelines. So there's a lot of work in front of us, but I thought I'll share with you the idea and the concept. Thank you very much.